Using the properties we learned about rhombuses, rectangles, and squares to solve for missing measures, and also to identify parallelograms and tell, can we determine if it is a rhombus, a rectangle, or a square, or maybe there's not enough information. All of that should be based on the given information in the problem. That could be from the way they mark the diagram to labeling angles on a diagram and such. So we're going to go ahead and get started. There's not a lot of to write here, so I'm going to ask you to underline some things. If the diagonals of a parallelogram are perpendicular, then it is a rhombus. So we are just going to underline diagonals, perpendicular, rhombus. So one of the ways they may indicate that these diagonals are perpendicular is with that little right angle symbol in the middle of the diagonals, right? So if there's one right angle there, we learned that they're all right angles because these two angles are congruent because they're vertical angles. These two angles and these two angles are supplementary because they're a linear pair. So one right angle indication indicates that all four of those are right angles. They might not put that there. They might tell you that RO is perpendicular to MH. That's another way that they might indicate that those diagonals are perpendicular. So we're going to label this one as a rhombus. And the next, this middle example, it says if the diagonals of a parallel bisect a pair of opposite angles, so we're going to underline diagonals bisect opposite angles, then it is a rhombus. So they have indicated that these angles and these angles are congruent. They've indicated that this angle, and this angle are congruent, right? We need to know, and we need to remember that what that's saying is this line is creating these congruent angles. So it's bisecting. So when a segment or a line bisects an angle, it creates two congruent angles. So we have to remember that that's what this is saying. This diagonal is bisecting this angle and bisecting this angle. They may tell us it bisects an angle by labeling them with the same number of degrees. So that's another way they might tell you they're bisected. They might tell you just with one pair of angles. But this is a rhombus, right? And this is all reviewed from yesterday, right? If the diagonals, we're going to underline diagonals again, of a parallelogram are congruent, then it is a rectangle. And the way they're probably going to usually tell you that the diagonals are congruent is either label the measure of them. They might mark them congruent. It's kind of hard to label the measure. They might label the measure like 5 and 5 and 5 and 5, right? Instead of giving us this, they're showing us that MH is 10 and RO is 10. So we have to know that that means they have the same measure, which means they are congruent. They may give it to us in instructions as a given information. They may write it like that. RO is congruent to MH. There's a couple different ways they can indicate that the diagonals are congruent, and you have to be looking for different ways, not just one way. So we talked about rhombuses, rhombi, we talked about rectangles. We didn't talk about squares. So if a parallelogram is a rhombus, or if a parallelogram has perpendicular diagonals, if a rhombus has congruent diagonals, what do we know about that parallelogram? It is a rhombus, it is a rectangle, but more specifically, it is what? It's a square, right? It's a square, right? So the diagonals are congruent, and the diagonals are perpendicular, now we know that the one parallelogram that both of those things are true for is a square. So when diagonals are perpendicular and are congruent, the parallelogram is a square. If it's just perpendicular, we call it a rhombus. If they're just congruent, we call it a rectangle. But if it's both, that's a square. Just so we're clear, if you don't have this part written, you won't get credit for the notes. Everybody caught up with me? No. You do not. Alright. Given that all of these are parallelograms, so that's what it tells us right here. So that's part of the given information. Can we conclude, based on how these figures are marked, if it's a rhombus, a rectangle, or a square? So remember, you want to give me the most specific answer. So if it's a rhombus and a rectangle, then you should tell me it's a square, right? Alright, so example 1. What do the markings on that diagram say? What do the markings on that diagram tell us? What do you think? Louis, what do the markings on example 1 tell us? Here? So those arcs tell us something about the sides or something about the angles? Sorry? The angles. So it's saying that this angle is congruent to this one, this angle is congruent to this one. What is it saying about the diagonal here? Doesn't that look like that one? So we can see that this diagonal split this angle into 2 congruent angles, and this angle into 2 congruent angles. So what does example 1's given information tell us? Yeah, it tells us that the diagonal is bisecting the opposite angles. So if the diagonal bisects the opposite angles, is it a square, a parallelogram, or a rhombus? A rhombus. So you should give me a reason. If you tell me what it is, you should tell me how you know it. This is a rhombus because the opposite angles are bisected, and I should have said by the diagonal. What do we know about example 2? So that parallelogram, what does that box in the middle tell us, Hannah? We have an example like it. Yeah, it tells us that what's perpendicular? No, parallelogram is not perpendicular. Look at the examples we gave up and right above it. So the diagonals are perpendicular. That's what that little box is telling us, right? It's telling us when those two diagonals intersect, it creates a right angle. If it creates one right angle, we know all 4 are right angles. So we know that this is a rhombus, like Hannah just said, because the diagonals are perpendicular. What is marked on example 3? What do we know about that parallelogram in example 3? It does not say that the diagonals are congruent. Because if the diagonals were congruent, then they would all have either 2 marks or all have 1 mark, right? So what is that diagram tell us? What do you think, Jesse? Can you tell me?
That the diagonals bisect each other.
The diagonals bisect each other. So which parallelogram do the diagonals bisect each other? A rhombus, a rectangle, or a square? All of this is a parallelogram. So the diagonals bisect each other in all parallelograms. So if you're having a hard time remembering it, I get it, but you got to start working on that. So we're going to say the diagonals bisect each other, because that's what it's showing here. But since that's true of all parallelograms, there's not enough information to conclude which one it is. They didn't give us any other information. We already knew that those diagonals would bisect each other or we should have known, because that is a property of all parallelograms. What does the information in example 4 tell us about that parallelogram? Caleb?
Is it a square?
No. What is the given information? What are they telling us?
That all sides are congruent?
Well, they don't tell us that. They would have a congruent mark on all sides, right? Or they would say AB congruent to BD is congruent to DC is congruent to CA. What does the statement right above that figure say, Caleb?
AD is congruent to CB.
So what is AD? What is CB? They're diagonals, right? So they're saying that the diagonals are congruent. So in what parallelogram do we know that the diagonals are congruent? Rectangle. We know a rectangle and a square, right? But we don't have enough information to say it's a square. We do have enough information to say it's a rectangle. So we're going to say the diagonals are congruent. It's a rectangle, but the diagonals are congruent. That's what this says. Any questions? All right, we're going to move on. For what value of x is the figure given? For what value of x is the figure in the given special parallelogram? You guys don't have this on your notes, I don't think, so go ahead and add it on there. Example 5 and example 6, we need to know that they are rhombuses, rhombi. We need to know that example 7 and 8 are rectangles, but I think that's already marked on your notes. So, if example 5 is a rhombus, they've marked those two angles with a measure, an algebraic expression that represents the measure of those angles. So, they've also drawn the diagonal, right? What do we know about the diagonals of a rhombus in relationship to some of their angles? If you don't have, I think Grace has her notes out for 6-4. 6-4 is going to be, they're really good notes to have out all chapter long, because it has all those properties of a parallelogram plus the new figures. So 6-4, and then we're going to be doing trapezoids and kites, I think, next, and it'll probably also have another list like that. So some of your notes are going to be more powerful for helping you study than others. So 6-4 is some that you should have. So what do we know about the diagonals of a rhombus? Right, so let's look here. So what part of these characteristics of a rhombus will help us find the measure of x? 7, the diagonals bisect a pair of opposite angles. That's right. So here, because it's a rhombus, we know that that diagonal is creating two congruent angles. if they give us the measure of those angles, now we can write the equation. So we're going to write that opposite angles are bisected in a rhombus. So that means they're congruent. You should have those angles marked congruent. And then we're going to write the equation. If they're bisected, they're split in half, that means, ooh. Let's remember to write that in. There we go. So you're going to write that equation and solve. It only asks for the x and not the measure of the angle, but we could find the measure of the angle of the rhombus, or the bisected angle, either one. So there are variables on both sides. Going to get them together by adding the opposite of the smallest. Add 9 to both sides. Divide both sides by 4. And that's equals 12. Let's look at the next example, example 6. They tell us it's a rhombus, or I told you it's a rhombus, so we wrote that. So we know the measure of those two angles. What else do we know about the diagonals of a rhombus? So, what else do we know about the diagonals of a rhombus? They're perpendicular, which means they form right angles. That's right. So now we know that this is a right angle. That means they're all 90 degrees, right? So this plus this equals what? 180. The sum of the interior angles of a triangle, we all know, is 180. And so we can write that equation and solve for x. I'm going to combine my like terms. 3x and 8x is 11x. 96 plus 7 is 103. We'll subtract 103 from both sides. Divide both sides by 11, and I know x equals 7. And I forgot to cover the box. I do want you to write that. Diagonals are perpendicular. The sum of the angles is 180. All right, example 7 and example 8 are both rectangles. What do we know about the diagonals of a rectangle? They're congruent. We also know, we know this one is congruent to this one. We also know that the diagonals bisect each other, right? Which means all of these are going to be congruent. Does that make sense? That means what we've created with the diagonals of a rectangle are 4 isosceles triangles. So just like in yesterday's homework, we can use the characteristics of an isosceles triangle, which says that these angles are congruent, right? These angles are the angles across from the congruent sides. That makes them the base angles. That makes them congruent. So we're gonna write base angles are congruent. And then we can write the equation that that angle equals that angle and solve for x. So go ahead and write your equation. Four x minus 12 equals 3x plus 4. 3x plus 4 equals 4x minus 12. Either way. Subtract 3x from both sides. X minus 12 equals 4. Add 12 to both sides. And x equals 16. Any questions so far? All right, example 8. What do we know about a rectangle? Tell me some things you know about a rectangle. What are the things that we know about a rectangle? Literally right in front of you. Someone throw me a bone here, reply. What do you think? All the opposite sides are parallel, right? So all of these are qualities of, or properties of all parallelograms. Remember, these two are the two that are unique to a rectangle. Which one's going to help us, Mason? 7? Yes, all 4 angles are 90 degrees. How is that going to help us with this one? To solve for x here. Yes, very good. So we need to know that there are 4 right angles, and we're going to mark those there. And so now we know that this angle plus this angle equals, what makes it a right angle? It's 90 degrees, right? So now we know this angle plus this angle equals 90 degrees. And then we're going to solve for x. So 8x plus 2 equals 90. Subtract 2 from both sides, and 8x equals 88. Divide both sides by 8, and x equals 11. Any questions? All right, you can scan and submit your homework, and then go ahead and start on your assignment. Do not pack up until 10:18. It's going to give you over 10 minutes to work on your homework.